Hello and welcome to this Simulator Spotlight presentation. My name's Jason Tranter, and in this presentation I'd like to tell you about the iTeachFundamentals Spring version of a simulator. Here it is here. Now, one of the traditional ways to teach about the waveform and frequency and amplitude is to talk in terms of simple harmonic motion. So here we've got a mass bouncing up and down on a spring, and that motion, that up and down motion, whether it's a mass on a spring or a pendulum going back and forward, maps out that simple harmonic motion, which is the fundamental characteristic of all the frequencies that we look at. Now, what we've done to make this a little easier to understand is here we've got a chart recorder, which at the moment isn't moving, and a blue pen which is attached to the mass. So when we start the chart recorder and it tracks across, now we have the most fundamental waveform, a waveform that represents a single frequency. Here we've got the passage of time, and here we've got the amplitude of the spring, of that motion. And we can go through and look at different springs with different stiffnesses, and therefore as we get into a stiffer and stiffer spring, we get higher frequencies. So now I've got more cycles per second. The chart is still moving at the same speed. In each one of these demonstrations, still moving at the same speed. So we still have the same passage of time, but here we have the lowest frequency, higher frequency, higher still, and the highest frequency of the lot. And now I can make a little bit more complicated and say, well, what if I had two sources of vibration? I've got two springs of different stiffness, they're attached to each other, and we get this odd motion. We've got the bouncing motion here, we've got the bouncing motion here. You can see this one's a lower frequency and a higher frequency, and when you add those signals together, we have the pattern that you see, two frequencies superimposed on each other. Now I have to personally add here that this is not actually the way that I personally prefer to teach the fundamentals of vibration. Even though it's traditionally done this way, personally I haven't seen too many springs out there in industrial workplaces, so I don't think this particularly relates all that well to trying to understand vibration for someone who's not interested in university courses and so on. But I know some people like to teach this way and explain it this way, so we have this simulator. We have other simulators that will demonstrate in other movies. For example, in this case, we look more closely at the shaft and we can see what the vibration's like. And just in case you're interested, we have another simulator here where we get to play with the mass and the stiffness and damping, and we can see how the waveforms all change. And here we go, and we can drag that down and see how the vibration changes depending on the stiffness of the spring and the damping here. But this one is a very simple simulator for explaining how vibration and frequency and amplitude relate to each other. I hope you enjoyed that little presentation. You see what one of our simulators can do. Thanks very much.